Hey everybody, this is a video to help us remember how to solve equations. Now, there are three parts to this video. The first part will be about solving equations, basic vocabulary, reminders about the essentials. Second part is about combining like terms, and the third part is about word problems. So if you're somebody that just needs to know about word problems, go ahead and skip ahead if you want, but I'm going to go ahead and just jump into linear equations. All right, now linear equations are just an equation of a line. So here's our first equation. It is an equation of this line right here, y equals 2x plus 1. And the first thing I want us to remember is variables. Now, variables are the letters that we use in an equation for a missing piece. Now, often we're solving an equation to find the variable's value. Whenever you see a letter inside an equation, we call it a variable. The other vocabulary I want us to remember is coefficient. Coefficient is the number next to our variable. So the coefficient in this equation, is 2 because it is next to the x. So if you ever see your coefficient, it's just talking about that number next to our variable or our missing piece. Now, when we have an equation, we're usually going to be asked to solve the equation. So if we look at this one right here, 5 equals 2x plus 1, we're probably going to be asked to find x, the variable x. The goal when solving an equation is to get the variable by itself. What that means is we eventually want it to just say x, bear with me with the tools, x equals something. That's the goal, is we want to know what x is equal to. So to do that, we have to start by getting rid of the 1 and the 2 so that we can figure out what x is. Now, you might remember that we have a set of steps that we follow in math class for this. So we're going to go through those steps and solve this equation together and do some examples. The one thing I want us to remember is that when we're solving equations, we always got to stay balanced. So you might remember that when we think about equations, we like to think of a scale. We have our two pieces of our scale. Whatever we do to one side of our scale, we have to do to the other. Because if we add something to this side, it's not equal, it's not balanced. Whatever we add to this side, we have to add to this side so it stays balanced. Whatever we take away from one side, we have to take away from the other. So whatever happens on one side of the equal sign happens to the other side as well. So let's figure out how to solve this. All right, here's my equation, 5 equals 2x plus 1. Now I want to get x by itself. To do that, I have to follow my steps. Number 1, use opposite operations to add or subtract. So now the first thing I'm going to be looking for is, you might remember I like to always start by drawing a line down my equal sign because I have a 5 on this side and 2x plus 1 on this side. Now I'm going to be looking for if I have any addition or subtraction. I see that I have a 2 next to an x right here. 2 next to an x, I hope you remember, means to multiply. So right now there's multiplication happening right there, but this plus 1 is being added, right? So that means I have to use my opposite operation to get rid of the 1. You might remember opposite is another word for inverse. Inverse is the fancy word for opposite. Inverse. I haven't mastered these tools yet, so bear with me. Now, what is the inverse of plus 1? What's the opposite? Well, it's minus 1. Now remember, whatever I do to one side of my equation, I have to do to the other. So if I subtract 1 on this side, I have to subtract 1 on this side. 1 minus 1 is 0. 5 minus 1 is 4. Now I'm left with 4 is equal to, what's left over here? My 2x. So I'm going to bring my 2x down. But I'm not done yet because x is still not alone. I want to get x all by itself. So then I'm going to look to step 2, then multiply or divide. And I have to use my inverse operations again. So I'm going to go back and say, all right, I know that 2 and x are being multiplied together. What's the opposite of multiply? What's the inverse of multiply? Well, that's a divide. So I'm going to divide by 2 on this side. Now, whatever I do on one side, I have to do to the other. So I'm going to divide by 2 on this side as well. 2 divided by 2 is 1x. Yay, I finally got my x alone. Now x is going to be equal to 4 divided by 2. 4 divided by 2 is 2. So x equals 2. Hooray! Let's try another one. All right, here we go. Same idea. I'm going to draw my line down the center. Opposite operations for add or subtract. I see 4 being multiplied with y here, and I see that I have, sorry about that, somebody's trying to call me, and I see that I have a minus 7. So I'm going to do the opposite of minus 7, which is adding 7. Whatever I do to one side, I have to do to the other, so I'm going to add 7 on this side. Now remember, negative 7 plus 7. Think back to our number lines. If I'm starting, here's my 0. If I'm starting at negative 7 and I add 7, I'm going to land at 0. That's the whole thing. We're getting rid of it. So that's 0. 13 plus 7. 7, 8, 9, 10. That is 20. So here we go. We have 20 right here. 13 plus 7 equals 20. And now I am left with 20 equals 4y, which is left over. Great. Now I see I have to multiply or divide. I see 4y being multiplied together, so I'm going, ooh, that color's hard to see. I'm going to do the opposite of multiply, which is to divide. I like to do this division bar, but with also my dots, so I remember that's what I'm doing. Divide by 4. Now I have 4 divided by 4. And whatever I do to one side, I do on the other. 20 divided by 4. 4 divided by 4 is 1y. So I'm left with y equals 20 divided by 4. Hopefully we know our multiplication facts. If not, use your calculator. 5 equals y. Boom, done. All right, let me get my pointer back. On to the next one. Now I've got some leftovers here, so I'm going to erase. Now you might notice that this equation is in a different bit form. My equal sign and my sum are on the other side, but that doesn't matter. It doesn't change anything. I'm going to draw my line down my center. Whoa, that was a crazy line, but it'll work. And let's start. Use opposite operations to add or subtract. Don't be fooled. 5 and d are still being multiplied here, so I can't get rid of 5 yet. The 11 is the thing that's being added on. This negative or subtraction sign is stuck to the 5. So this really says 11 minus 5d. So the negative or the minus stays with the 5. I'm going to deal with the 11 first because it doesn't have a variable. It's just being added or subtracted. Since it's positive, I'm going to do the opposite of positive 11, and I'm going to do minus 11. So I'm going to subtract 11 from both sides. 11 minus 11 is 0. 46 minus 11. 6 minus 1 is 5. 4 minus 1 is 3. Boom, 35. Then I'm going to bring this down. Here's where you remember you're not going to be fooled. That negative is staying with the 5. Minus 5d is still left here. All right, now I can multiply or divide to get that d alone. Now I'm very careful in remembering that I have to divide by -5, not just 5, to get rid of that whole thing, -5. So I'm dividing by -5. Whatever I do on one side, I do on the other. -5 divided by -5 leaves me with D equals 35 divided by -5. Let's just do the numbers first. 35 divided by 5 is 7. Use our triangle for negatives. Remember, we make our weird smiley face triangle. Now I have a positive divided by a negative, so I cover up the positive, I cover up the negative. My answer is -7. Phew, you guys are crushing it. Now, you're going to get to practice this in your work for today, so I'm just going to move on to the next section. But I highly recommend you trying one of these problems on your own. If you are interested in doing that, you can pause the video now and give it a try. If not, we are just going to go ahead and move forward to